right? So VR2 equal to VGSQ, yes? This is we call VGSQ, correct? Which is not known yet. And then this current is IDQ, yes? Same here. So therefore, for us, IDQ R sub S, yes? Okay, and IDQ is a function of VGSQ, yes? It's what? Kn VGSQ minus VTN to the square of to the power of 2, yes? So now if you put this here, right? So VR2 is equal to VGSQ plus Kn VGSQ minus VTN squared. So now you can see there's only one unknown, yes? The unknown is VGSQ. All right, let me see what's the number I have here. Okay, according to my notes, VGSQ is equal to 3.6 volts. Okay?
Yep. RS, we lost RS.
Huh?
And VGSQ.
Oh, times RCS. Yes? Yes? All right. Now what? Now with that, I can go back, yes, go here to find the value of IDQ, correct? So IDQ equal to Kn, which is 0.5 times 10 to the minus 3, yes? Because it's milliamp per volt square, times this 3.6 minus VTN. VTN is 2, right? Square. So 0.6, what is that number? 1.6 square, yes? 3, so 1.5? Instead of 3, yeah, yes? So, okay, huh? And then, so from here you can find G sub m is 2Kn VGS minus VTN. So that's about 1.55 milliamp per volt. Okay, so that's all you have to do for the DC analysis. Yes. Okay, now go to the more difficult part, AC. Okay, so you go from the left, yes? So E sub I, yes? And R sub I, okay? And you have a capacitor, C1. And then we have this guy, R1, compared with R2, correct? Okay, this goes to the ground. And then this is connected to the gate, right, of the MOSFET. The source is RS, right? The drain is connected to R sub B to the ground, and then you have C sub 2, and then you have R sub L, yes? So that's V sub O. All right. Then about model, we should have two capacitors, right? One is called CGST, the other one is called C sub N, yes? And then you should have a current source between the drain and the source, yes? G sub N VGS, so this is VGS, yes? Got it? Any questions? You have to know how to do this, yes? We have done this many times. Okay. Now, what do you want to do first? We can try to find A sub V max first, right? Okay. Now, when you do A sub V max, according to the shortcut, yeah, this is short, this is short, this is open, right? Okay. So what is V sub R? Is minus G sub N VGS times R D imperial with R sub L. Yes? Okay. Then what about V sub I? Maybe I should draw this one more time. Right? This is under the ideal condition, yes? This is R sub B impaired with R sub L. Correct? Yes? Under the ideal condition. Okay. So V sub I. So let's call this. Can I call this V sub prime? Can I? Okay. So V sub prime is a portion of V sub I. Yeah? Okay. Based on the voltage divided rule. Yes? Yes? That's V sub I. So I can switch, I can put V sub I on the other side. Yes? So V sub I becomes what? R sub I times V sub prime over R1 impaired with R2, correct? No?
Yes.
Yeah. Okay. See, my goal is to try to get this in terms of what? In terms of VGS. Yes? So now I can try to figure out what is V sub I as a function of VGS. Okay? So this is V sub I, right? So V sub I is this plus that, correct? Okay? So V sub prime, sorry, is equal to VGS plus, yes? Plus that current is a current, which is GM VGS R sub S, correct? So you put this in, you take the ratio. So A sub B max will be equal to B sub O on the top, so minus G sub M BGS RT impaired with R sub L divided by B sub I. Yes, this guy. And times B sub prime times BGS 1 plus GMR sub S, correct? So BGS cancel. Ooh. Do I have a value for that? I don't have a value for that, okay? But let's say this is a 10, right? Okay? I just make up a number, okay? So if this is 10, then this will be 20 dB, correct? Should I keep that? Okay, I should. You guys should come back here. Erase that. So now we have found A sub B max. Next we have to try to figure out the corner frequencies, correct? So if you look at C sub 1, on the left hand side you have R sub I, right? On the right hand side you have R1 in parallel with R2, correct? And anything else? See, when you focus on C sub 1, this is open, this is short, right? Okay. So if this is open, yeah, it's open, right? So you only have R1 in parallel with R2 on the right hand side. Yes. Yes. Okay. So therefore, top the RC time constant associated with C1 is equal to C1 multiplied by R sub I plus R1 equals R2. Yes? All right. And this, what is C1? C1 is 1 microfarad, right? So it's 10 to the minus 6 times R sub I. R sub I is 10K plus R1 in parallel with R2. What do you have? That is R1 in parallel with R2. It's I would say about what? 166 in parallel with 234, right? So it should be less than 166. 140? Huh? 150? What do you get?
97,
90?
97.
Oh, that's much less. Okay. 90. Hey, yes?
97.
Oh, 97. Okay, make it 100, huh? 100K. Okay. So therefore, it's about what? About 1 point. So it's a 1.1 times 10 to the what? Minus 3. Yes? No? Okay. 10 to the 3. No.
No, that's about 0.1.
No. Why is it? this is 110K, right? So it's a 110 times 10 to the minus 3. So it's a 0.11, yes? Okay. Then omega associated with C1 is 1 over tau C1, so it's 1 over 0.11, so it's about 10. Yes? Read it for a second. Okay. That we get 1 down and 2 more to go. Yes? Huh? This is 1.1?
It is full. It's correct.
Look, we should not make a mistake on that, right? I mean, it's so simple. I can make a mistake here, but you cannot. Huh? Okay, the next one. Let's say what is the RC time constant for C sub 2? Yes. All right, then you have to put a test voltage. Yes. So basically, this is what you have. Right? So you want to find some R prime here. So this is what? R sub L, R sub B, yes? This is R sub S, yes? This is R1, integral is R2, correct? This is R sub I, Gn, VGS, right? So this is VGS right here. Correct? Okay, so if you look at this note, IT equal to VT over R sub D plus Gm VGS, yes?
VGS is just between the gate and the RS.
Yes, that's right. Yes? Okay. All right. So, what do I know? I know this plus that is equal to what? Huh?
0.
This plus that is the same as that, right? And there's no current. So it must be 0, right? So VGS plus that, which is Gm VGS R sub S must be 0. Yes? Because this plus that is the same as that, but there's no voltage, yeah? There's no current. So, and for this to be true, the only solution is VGS must be 0. Yes? So you put it here, you can see that your R prime is simply what? R sub B, right? All right, so if you focus on C sub 2, on the left hand side you have R prime, right? On the right hand side you have R sub L, correct? With R sub prime is R sub B. So therefore tau C2 is equal to C2 times R sub B plus R sub L. This is 0.1 micrometer, is it? 10 to the minus 7 farad. R sub B, what was R sub B? 4K plus R sub L 20K, right? 20K. So it's 24K, right? So it's 24 times 10 to the minus 4, right? So it's 2.4 times 10 to the minus 3. Okay, so omega associated with tau 2 is 1 over tau C2 is 1 over 2.4 times 10 to the minus 3. So what is it? Oh, 1 divided by 2.4, that's
About 400.
5, huh? 400? Okay. All right. So the last one. The last one is the one that is that's associated with the intrinsic. Yes? Associated with the intrinsic. So now, if you look at the, I can combine the two, right? So CGST plus C sub n, correct? Okay, and then you have this guy to the ground, R sub S, right? And then what do you have? And then you have R1 in parallel with R2 to the ground. Yes? And then you have R sub I, and then you have B sub I. Yes? So basically, that's what you have. Yes? The right hand side, you don't have to care too much because it's open. Huh? Correct?
Should we open the voltage source too? To short that?
Well, yeah, we haven't not done it yet. Okay. So basically, you have to take this one out, right? Let me put it back here. Okay, so basically you want to take this out, right? And then you look into the left. Yes? So you have R sub I, right, to the ground. R1 in parallel with R2 to the ground. Yes? And then this is the two terminals, right? Where you're going to put the test voltage. Yes? And then you have this the ground, R sub S to the ground. Yes? Where's VGS, by the way? So this is VGS, right? Is it? I think I would probably need to take a look at that. That's G squared VGS, right? Anyway, here is the I test, right? Is that correct? So you can combine these two. So you get a single one, R sub I in parallel with R1 in parallel with R2, right? And then you have R sub S, right? And then here you have the B test. I test. shows the current. So I test equal to Vt, right? Vt divided by Ri in parallel with R1 in parallel with R2, right? Plus R sub. Yes? That's the current. So, therefore, if you look at the, let's say we call this R double prime, right? So therefore, R double prime is simply Ri in parallel with R1 or in parallel with R2. Right? Plus R sub s. All right. Then, what else? Yes, yes.
For the capacitance, the internal capacitance, is it CGST in parallel with CM or is plus correct?
When they are in parallel, you add it. It's not the same as the resistance. Yeah. When you have two in parallel, you just add them. When you two in series, then you treat them like parallel. Yeah. Okay. What else? We have not calculated C sub n, right? This is very strange. Bad. Yeah. Okay. So basically, the tau associated with the intrinsic, right, is equal to C sub n plus CGST times what? R sub prime on to the left, correct? And then what is on to the right? Huh? It's open, right? So in parallel is so it's equal to C sub n plus CGST times R double prime. So there's only one thing left to do. Yes? What is it? There. Yes? So I gave you the formula. C sub n is equal to CGDT 1 plus G sub n, the magnitude B sub O over VGS. Right? And in this equation, everything is known except for that. Yes? So what is V sub O? Yeah, if you go back to the AC circuit, you will know that V sub O is equal to G sub n VGS times RT in parallel with R sub L. Correct? So therefore, if you put it here, your C sub n will be CGDT 1 plus G sub n, what? RT. Oh, I had two G sub n, correct? G sub n, G sub n. Is that correct or not? Let me see. Okay. There's no G sub n. Okay, I made a mistake. So please change the formula. Okay. So it's 1 plus the ratio of V sub O to VGS. So it would just, it was just 1 plus G sub m R sub P in parallel with R sub L. Yes? So I got a number for that, about 0.6 picofarad. Remember, this is given, huh? And this is known, all these are known. Okay, so tau intrinsic is 0.6 picofarad plus what was GDST? GDGST was 1 picofarad, right? So 1 picofarad, yes, times R double prime. And I got about 14.2 nanosecond. Nano, by the way, is 10 to the what? That's right, okay? So omega intrinsic is 1 over that, yes? So about, what do you think? Huh? 58 times 10 to the what? 7? Yes?
68 times
10 to 6. All right, thank you. So it's about 6 times 10 to the 7. Yes? Okay, go. Now, we've got everything we need. Yes? Now, if I do the body power, A sub B, right, versus omega. You have to remind me what were the corner frequency we have found? Huh? 10, all right, thank you. Second one? 100, all right. So this guy is 6 times 10 to the 7, yes? Okay, so there are 3. And the bandwidth is divided by the 2 corner frequencies. They are located mostly to the middle, right? Okay, so that's the boundaries. So that is A sub B max, which I say was 10, right? dB. Oh, yeah. dB. Right, so here we have drop, right? Here you have more drop, right? So this is minus 20 dB per decade. This is plus 20 dB per decade. This is 40 dB per decade. Yes? So that's it. There you go. Any questions I can answer? Homework or anything? Homework?
From 27.
27? I don't have the book. Anybody has the book? Nobody carries a book.
I got it.
You got a book? Oh, okay, so there was a question about what, 7.27?
Yeah, 727.
And make some assumptions, vague, not necessarily vague, but you have to just assume something for IDQ and BDSQ.
But couldn't we go backward from the frequency rotation? Then with
All stochastic should be specified. So that means what? You have to design? Okay. Let me see if I can solve it. I'm not sure because I'm not prepared for that, but I suppose. solve sometimes you don't get enough information. Is that what you're saying?
Yeah.
Okay. Maybe that's the case. I'm not sure. So that becomes an open-ended problem, right? Open-ended means you can assume something and get different answers. Okay. So here's the circuit, right? Doesn't look too bad. Oh, R sub I 200. Okay, good. Here we have R sub I is about 200, right? Then we have a capacitor, and then it's a MOSFET. Yes, it's a MOSFET circuit. So this is short to ground. We have R sub B, R1, R2, right? VDD. Anything else? And then we have a C sub L, so that's B sub L, right? So this is R sub whatever C sub Z. Yes. C sub C. Yes. Okay. What is known? R known.
Nothing.
Nothing.
Except
Oh,
the frequency.
the voltage.
Yeah. The frequency.
9 volts.
The frequency is
Okay, so the bandwidth from 200 to 3K, yes? And the magnitude is 10. Okay, so this the, right? So you have 200 to 3, this is 3K?
Yeah.
3K, in hertz, by the way, okay, hertz. Okay, and then the magnitude is 10, which is 10 dB, yes? So that's the information. That is the body plot you have to design, yes? Okay. So, yeah, probably don't have enough information. Nothing else is given?
So could we go backward from the top?
No KN, no BT, nothing?
Then we should find the parameters of the MOSFET.
How do you do that? So that's, yeah, this is.
The way they do it in solution manual is they assume an IDQ and a DQ, or a DQ.
Oh,
And
so they went ahead, just assume that?
they also assume the value of R1 plus R2.
Oh.
So why we couldn't go from the
And they assume V2.
Yeah.
what about to go from the top?
So this is not a good problem to assign. Yeah. So next time, if I would teach it again, I would drop that problem. Okay. Anyway, but you know how to solve this, right? Yeah. Okay. So let's assume you know values. Okay. So let me go through this very quickly. So basically, this one is associated with what? With CEC, correct? And this one is associated with C sub L. Huh? You know that. Okay? So that means F associated with CC is 200 hertz. Yes? So therefore, omega associated with CC is what? 2 pi times 200. So that's about 6, right? 1.6 times what? 1200 radians per second. Yes? Okay? And therefore, tau associated with CC is what? Is 1 over omega CC, right? Yes? So it's equal to, make it 1,000, so it's 10 to the what? Minus 3, yes? Second, by the way. And this is equal to CC times, right? To the left, to the right.
So I
Yeah, it will be just R sub for us, R1 in parallel with R2, okay? Yeah. Now, this is supposed to be given, okay? So therefore, you can find CC, yes? Okay. For C square, you know, you have to put a test voltage, yes? Okay, so, no, okay. Oh, but this also can give you something, huh? What does it give you? It can give you, let me think, huh? Assuming you can find G squared, yes? G squared times RD from.
Yeah, that's the one.
Okay, so anyway, there are too many unknowns. Yes, I have to agree. Yeah. Definitely, you will not see something like this.
So do we not worry about it in the homework then, or what?
Okay, yeah, let's drop it.
All right.
Yeah, let's drop it. Okay.
I was actually like about to start it right after. Yeah. I hadn't even looked at it yet. I just read the problem. It saves me a lot of time.
I hate problems like that.